Welcome and hello. This is a video exercise in HEC ResSim. And in this exercise, I'm going to talk about developing a guide curve, specifically using an example here in Northern California at Oroville Reservoir. All right, so I have my HEC ResSim version 3.3 up and loaded. Since this is an exercise, I will be going through all the steps of the development. So bear with me. All right, so that means telling you to click File and New Water, or sorry, the module needs to be Watershed Setup and then File, New Watershed. All right, so I'm going to go ahead and name my watershed. It's going to be called Video 5. Okay, and open. Okay, English units, and then we'll select the time zone. All right, first I'm going to sketch out a stream alignment. So I'll click the stream alignment tool, hold down Control, single left click a few times, continue holding down Control, and then before my last click, I'll let go Control, single left click, give that stream alignment a name. Now I'll select the computation point tool, hold down Control, single left click on the stream alignment, and we'll just give it a name that's generic. Zoom in a little bit. All right, let's build our reservoir here. So I do a single left click on the upstream and then the downstream while holding down Control for the first click. And we'll call that Reservoir 1. All right. And then one more computation point down here for good measure, CP4. All right. I'm going to go Watershed Configuration Editor, create a new configuration. This will make it easier to build our network in just a moment. Okay, I'm going to go File and then Save Watershed. We have a config1 saved with this reservoir. And then I'm going to head over to the reservoir network module and then create a network by going network new. We're going to select config1 as our configuration and then name the network. Network 1 is fine. And then new. So it brought in our reservoir and our junctions. And I'm going to go ahead and connect the network by just clicking the reach tool, holding down Control on the upstream. Go ahead and click on the upstream junction, let go of Control, and then single left click on the downstream junction. Do that again for the reach that's downstream of the reservoir. And we have a connected network. Okay, I'm going to go ahead and just click the junction tool and assign some inflow to this upstream junction. I'm going to click the local flow tab and then call it inflow at CP1 and click apply. Okay. Now let's go ahead and edit the reservoir. The actual inflow for this junction we will define a little bit later when we create an alternative. But for the time being, I just had to identify that there was inflow here, and that's why there's a circle icon around this junction and not around the other junctions. Okay, let's go ahead and edit our reservoir here. So edit reservoir properties. As I mentioned in the intro, I'm going to use some real world data, and that's going to be using a data for a reservoir up here in northern Colorado. Just kidding, California, called Oroville Reservoir or Oroville Dam. I'd like to first rename the dam as dam. First, I'm going to start with the pool elevation. This is the reservoir geometry. Now, I don't have insider information, but based on the website, the CDEC website, let me pull that up real quick. Here it is for Lake Oroville. I'll include this link in the description of the video if you want to see what it says. But what we learned from this is that there is a total capacity of 3.4 million acre feet, and it gives you some data about today's current status, but that's not too important. The reservoir elevation, that's the water surface. Here's the current storage. And then what's also important for this exercise in ResSim is these plots here, particularly this blue line and then the elevation. So I can tell like the storage goes from 227 up to the total capacity of about 888, maybe a little higher. And then the historical average here in the legend is the blue line that's filled in below. So we will use that in just a moment when we develop the guide curve rule. So let's go ahead and head back to ResSim. Based on that information, I have a pool geometry I'm pasting in here. I'm using 3.4 million acre feet of storage instead of 3.42. So close enough. And then as for the elevation, that's pretty much the same as we saw from the online data. So I'm going to go ahead and click apply. Over on the dam, I'm going to specify the top elevation. We'll call it 890. I'm not sure about the dam width. I'll just say 500. And then let's add a controlled outlet. Okay, I'm pasting in some controlled outlet data with a total CFS, with a total release of 20,000 CFS. And we'll say there's two gates, so 40,000 CFS is probably plenty. I'm going to go ahead and click apply. Okay, over in the operations tab of our reservoir, I'm going to, first of all, create an operation set and then click apply or okay. Now we have our zones for flood control, conservation, and inactive. So I'm just going to set this to the minimum and maximum of the pool geometry. So inactive would be the base elevation 240. It's probably higher than that, but for the sake of building a model, we'll just go with that. And then conservation is we'll say it's the top 890, and then flood control. Oh, hold on, flood control is 890, and then the conservation zone we'll put it somewhere in the middle for now. We'll say maybe 700. That might be a little bit low, but we'll see what happens. And then click apply. All right, let's go ahead and create an alternative now. So we will return to this conservation zone because it's defined as the guide curve. And of course, the guide curve is not a constant elevation for all 12 months of the year. All right, so I'm going to save the network and then click alternative, edit. I'm still in my reservoir network module. So you should be able to click alternative, new. We'll just call it alt one. And it's based on network one. So that's good. All right, so for the run control, we'll go ahead and select 1 hour. Operation will be our operation set one. I just called it operation set. Now for look back, we need to identify the look back elevation of the reservoir and then the current release. So we'll start it at the guide curve elevation, which we said was 700 for this alternative. Okay, for the release, I'm going to start it off at 7,600, 7601. I'll show you why in a moment. It is basically the very first inflow value for the time series that I'm going to define. So I'm going to go alternative and then save. The last tab we need to define for our alternative is this inflow at CP1, but I don't have the data set ready quite yet. So we're going to do that now and then return to uh, properly assign the time series data set to this inflow. I'm going to click close and then tools, HEC DSS view. I'm going to just open up a new .dss file. I'm going to create one right here in my video 5 directory, which is the watershed directory. I'll call it time series data and then create. Okay, let's say this is the year 2023. So we have 365 days and I have daily inflow. So let me set up the time series, and then before I paste in the data, I'll show you where I'm getting this data. So just like the reservoir geometry, we and the guide curve, we will have some real world data to be working with, even though I understand there are a lot of corners I'm cutting in this analysis. Okay, so we're going to go up to data entry, manual time series. And if you're unfamiliar with DSS view, then I've created a number of tutorial videos on a different playlist describing what's going on here. So can't go into too many details, but I will say the project is Feather River. I think it's the Feather River, whatever. Oroville Dam, and then the C is for the parameter. So this is going to be inflow. And then 1 hour is actually going to be 1 day. So let me change this to 1 day is the time interval. And then the F is the user defined label. I'll just leave that blank. No, what I'm going to do for F is I'm going to say 2000 to 2023, and then its average daily inflow. How I'm getting the data is the values for the inflow. It's going to be the average flow for each day of the year. So if you're familiar with California hydrology, we get our rain in the winter time, October through April for the most part, as well as some snow melt that's from March until June. And then in the summer, late summer and autumn time, we get really no inflow into our reservoirs. So what I'm going to pull up to demonstrate is over on the CDEC website. If you scroll down over on the right, there's a couple really important links, like historical data is where you can get the data. And then the station search is right here. So if I open that up and I typed in Oroville, yeah, and then click the checkbox and then search for data. We have any name matches. So Oroville Dam is .oro. That's the ID. So that's all I really need from this page. And then over in historical data, if I type in the station number, actually, I want to click on this web services because it'll download directly to Excel, but it's a similar page. So I'm going to type in ORO is the station ID for Oroville Dam, and then I have my data sets. So I could go ahead and select 76 daily. That's the reservoir inflow daily. There's also an hourly, so be careful about that. And then after that, I would select the time, date time, and I found that it goes back to about the year 2020 reliably. It goes back a few years before that as well. I just used about 24 years of data, and I click the Excel button. I'm not going to do that because I already have it over on this screen here, and I'll bring it in. So along the top, I've got the year, and then the first day of the year, the second day of the year, the third day of the year, the fourth day of the year, and so on. I cropped off the last day of the year for the leap year years, and I'm just going to roll with that assumption to make things easy. There was a little bit of data cleanup, but for the most part, it was all good looking, reliable looking data. Okay, over to the right, I did a average. So 7601 is should sound like a familiar number. It's the average January 1st inflow to Oroville Reservoir from the years 2000 to 2023 inclusive. I'm going to use this 365 records in the average, and I'm going to copy it to my clipboard. And then that's what we're going to use for our time series inflow. Let me fill out a few more data points here that I need. So this is going to be the start date. It's going to be January 2023. I'm going to say it's 2023, even though I'm using data for the past 24 years. Start time, this is daily, so I'm going to say 2400. Units will be CFS, and then instantaneous value is fine. Okay, I'm going to paste in those average inflows, and it only took one value. 1 second. Okay, there we go. So let me just confirm there's 365 records. There is. Save, or no, I don't need to see that again. Okay, so here is my DSS view window again, and we can just take a quick peek at the records. And sure enough, most of the inflow is coming in here at the first half of the year, and then a dry summer autumn period, and then it starts getting wet again at the last month or so of the year. All right, that looks good. We'll head back over to ResSim and open up our alternative, and then we're going to select DSS path. Let me open up that file. Here it is. Okay, and then I have to select the record. This is it, and then click this Set Path Name button. So when I do that, I'll close that. It populated this record with the same time series data set that we created from our Excel data. Okay, so let's save the alternative, close, and now we can move over to, let me save the network, select simulation module. No simulation has been created yet, so let's do that. Simulation, new, simulation 1, and then the start time will be, you know what, I'm going to start it on January 2, and then the look back period will actually be the first day of the year. And then that'll be the first. This will be December 31. and then we will do 2400 hours. And actually I had some issues with edge effects, so let me just change this to the 30th just to be safe, and this to the 3rd, and then I'll start it on the 2nd. Okay. So that means the look back data would have to be, sorry, 6822. So let me just modify that as well. Okay. And we are ready to compute. Let's see what happens. Okay, so the simulation computed. Let's take a peek at the reservoir and see how it behaved. And that looks pretty great. It looks like the guide curve was able to be achieved. Okay, so what I'm seeing here in the plot is, let me just resize this briefly. The releases from the reservoir basically match the same thing as the inflow because there was plenty of storage. There's no downstream release rules assigned to our zones. Constant 700-foot elevation is not a problem. So what I want to do now is stress the system and tell it that we have some downstream demands, which is what we do have in reality, because there's agricultural demands. Southern California, of course, needs the water for their orange trees and everything else. People too, people. So let's go ahead and I'm going to add a second alternative, but now I'm going to modify. I'm going to add a rule to require specific volume releases from the reservoir. I'm going to go back over to the network reservoir network module, and then let's go ahead and modify reservoir properties. And then I'm going to go to the conservation tab and add a rule, minimum release. So keep it really generic. We're not specifying exactly what it's for. That's fine. It'll be a release function and it will be based on date. So define date. That's fine. Now we can put in the date and then the required release. Okay, so I'm back over here in CDEC to get some data ideas. I have no idea what to put for my release, but thankfully there is data available online. So I'm just going to go back and instead of selecting inflow, I'm going to select the historical release data. So reservoir outflow, yeah, sensor number 23 and daily, that's reservoir outflow. I'm going to change the date time to, we'll just do 2023 and we'll do all year. So the start of the year is, let me just key this in. And then I'm going to, let's just download it as Excel. So hold on. Okay, the Excel data popped up here. Here's the actual values. Okay, one record per day. So 336 is January 1, 348 is January 2. According to this is only for the year 2023. I kind of want to get a monthly sum. So one moment. Okay, one thing that you may run into is CDEC will sometimes export the data into Excel, but it'll be like in a text format. The numbers will be considered text and have commas, and you may need to convert that to text or convert to number. So I just did that, and apparently the average release in CFS for January of 2023 was 461. So I'm going to do the same thing for the other 12 months, and bear with me. I probably could have a macro or something written to automate this, but I haven't done it before, and I'm just trying to make a video. So bear with me doing it the slow way. Okay, so what I have here are the releases from Oroville in CFS, and that's kind of averaged over the month. So I'm going to use these as my downstream release rule for my reservoir. So I'm copying them to my reservoir, to my clipboard. Okay, going to paste them in. All right, that's all right. Let's go ahead and make it. Let's see what cubic looks like. Okay, let's see what step looks like. Let's go with step and then apply. Oh, right. We need to say this is the minimum. Date, step. All right. Okay. And then apply. We'll save, but not close. And then let's add that to all the zones. Okay, looks good. Apply and okay. Now let's go ahead and create alternative 2. So we'll go alternative, edit, and then new. Call this alternative 2. And then the description will be includes downstream release rule. Okay. We will say it's hour again. Pretty much the same information. The look back will be, okay, so I'm going to go with 700 again, and then 7601, or hold on, we said 6822. Back, time series, we will select the same time series as before. And hold on, I think I have to copy this again to my, yeah, I got to copy this to the simulation one directory. Okay, I got HEC DSS view up. I thought I could copy it in that other interface. I'm going to go ahead and open up the time series dataset that we created. There it is. Now I'm going to select it and then edit, copy to, and then copy it to the simulation one slash simulation.dss. And then yes. Okay. Okay. I'm not sure if that was necessary or not, but it's the same inflow we'll be using. And there it is. All right. So let's go ahead and save that. Head over to, let me save this. Yeah. And then in the simulation module, I'll go ahead and add alternative two to simulation one. Then let's go ahead and set it as active and then compute. All right, let's see what happened there. So we'll check out the plot of the reservoir. And what we have is interesting. Okay. So on the top, we have our reservoir pool elevation. It starts off at the guide curve for the first couple months, and then it starts to struggle because of the releases. And we see that for the first couple months, it's releasing all of the inflow to basically keep that water surface elevation the same. Because this green line is above the inflow, the outflow is above the inflow, the elevation in the reservoir starts to go below the target of 700 feet of elevation, and that continues for a couple months, and then you can tell somewhere between July 1st and September 1st, probably like around the beginning of August, it just completely gives up. That's what this green line is about. It can no longer satisfy the demand, and we have problems downstream. That's what I expected to see, and that's why we don't have guide curves that are uh, a complete flat line for 12 months of the year. So what I want to do in the last part of this exercise and the third and final alternative is to modify this guide curve to something that's more realistic based on the CDEC data, and then run the simulation and check out this plot. And hopefully what we'll see is the reservoir will rise and have enough storage to satisfy the downstream demands that we now assign to those rules that's assigned to both of the zones, the conservation zone and the flood control zone. All right, so let's close this and then head back over to our reservoir network. Click on the reservoir tool, edit reservoir properties. Now what we want to do here is instead of a constant 700, we want to use a more intelligent line. Okay, so I'm back on the CDEC page. And if I scroll down here, I pointed this out earlier in the video. We have the historical average in light blue. And I'm not sure if you can see it on the screen very well, but basically it starts at October 1st and then it ends at October 1st. So we have like a January, February, March. And what I'm going to do is use the elevation corresponding to the beginning of those months. So January 1st would have a certain elevation, February 1st would have a certain elevation, March 1st, and so on for all 12 months. So I've done that already. So I have those values copied on my clipboard. I'm going to just right click, paste them in here. So you can see the numbers are well above 700 feet, which corresponds to a much larger storage. So now the simulation, I think, should start at 780 instead of 700, and then we can use the same inflow as before, just thinking ahead for when we set up our alternative three. So I'm going to go ahead and click apply. And then sure enough, we have that new curve drawn in here in the thumbnail sketch. So that's what we're going for. And then I'll go ahead and click OK. Then let me save the network there. And we'll create alternative three. I go alternative new alt three. Okay. Once again, we'll use the 1 hour time step and keep all the default settings here because those were fine. Operation set. And then we're going to start with a elevation starting at 780. And then the look back is going to be 6822. That will probably adjust after the first day anyway. And then our time series will be the same time series as before. So that is, I got to navigate to the RSS simulation one here. Boom. And then it's this one here. Okay. Set path name. I think that's correct. Okay. Looks good. Let's go ahead and save. Alternative three is now in our table up here. So let's save the network and head over to the simulation and now add alternative 3. Very cool. And then we'll set that as active and then compute alternative 3. All right, let's see what we got here. And that is much, yeah, that's awesome, actually. Look at that, guys. Uh, we have a similar situation. I mean, of course, we started with more water, and it looks like the water surface elevation couldn't quite keep up with the guide curves. But what I got excited about when I first saw this was the demands downstream were met for what looks like the entire year, even though the surface elevation dropped down to something like 450, and it's way off the guide curve. So maybe I need to adjust that. But this is really exciting to be able to go through these three alternatives in this example with you, where we first started off with no downstream demand and a constant guide curve elevation of 700 feet. Alternative two, we added downstream demand and realized 700-foot constant guide curve was not sufficient. So we added in a guide curve that was more realistic. And sure enough, in alternative three, we realized our downstream demands could be met. So hopefully this was exciting, and I gave some helpful information about the CDEC website and how to get some information that's historical, and also the reservoir elevations and geometry. So I hope that was helpful.